And then what we have is the cumulative frequency. Which we have a IQ score still, the same example we use. And the same example we had seen before, right, of the IQ score. Then what the cumulative IQ score doing is construct it to a cumulative distribution. So we need to attach two extra columns. The first column is cumulative class. And then it's cumulative frequency. Which by the word itself, right, literally is just means accumulate every class together. Which means, well, the first class has two people. That is itself, right? The bound we have, or the limit we have is between 50 to 69. That's everyone below 70. Right, that's the cumulative class. And the frequency we have is just itself, because that's the first class, it accumulates itself, right? Then for something in the second class, it accumulates the first two classes together. Right, so everything is from 50 to 89, so that is the classes below 90, right, below 90. Then cumulative adds together of the first two classes, that should be 35 students, or 35 kids, right, 2 and 33. The sum of first two classes. Then the third one is cumulates the first three classes together, that is the IQ score below 110. That will be not only the 35, but 35 more. Right, then the fourth class one accumulates them together, it's everything below 130. What we have is 7 more. 77 kids, and everything altogether that's below 150, which is the upper boundary of this one, which we get 78. Just one more being counted. And that's how we find the cumulative frequency distribution based on the original IQ score. Why we introduce the relative frequency and cumulative frequency distribution is because we need to use them to count into pictures and to graphically display what the distribution looks like. We need to use different curves for different purpose, basically. And the relative frequency and the cumulative frequency sometimes are helping us to do the question. Go back to the continue level, try the example. To construct the cumulative frequency distribution. Right, so we know that we need the cumulative classes. Right, sometimes when we graph them, we do not need the cumulative class column. When we do the graph of the object, we just may need is the class boundaries. Right, then we have 5 classes, then we need 5 classes for the class boundaries, right, or cumulative classes. Right, the first one is continue level below 100, right, that's apparently level of them. For the second class, that's taking everything from 0 to 199, which is below 200, and so on, right? Below 300, 400, and the last one is below 500, everything we take in. And then for everyone below 200, that's the sum between sum of 11 and 12, right? That's 23. For the one we take less than 300, that's 14 more. Right, for the one less than 400, that's 1 more. And then at the end, 2 more is counting in. Like the similar example, right? 11, 23, then let's have 14 more, 37, 1 more, 38, then 2 more, we get 40. Then we move on to the next section to graph the frequency distribution. Now we actually cover different graphs to go. The first one is histogram. Bar graph. Right, so histogram using the frequency distribution table, right? We have a bar graph, which the horizontal scale represent the class of data values, and vertical scale represents the frequencies. Right, so we'll see, right, how to draw it by looking at the example. But still, that is what we need, the class values and the frequencies, basically. So that's a usual histogram for the IQ score. And the frequency. So 33, 35, 7, and 1. Right, that is the class we need, right? Then for a histogram to draw, we need a class boundaries. Like 49.5 to 69.5, 69.5 to 89.5. And therefore, together with the frequency and the class boundaries, we're able to draw the histogram. Right? A histogram basically is a bar graph, but it is a bar graph without any gaps. Right? So we need to use class boundaries. That we draw it. The horizontal scale is the IQ scores. The vertical scale is the frequencies, which is up to 35. Right, 5 as a gap. And for the horizontal scale, we use the class boundaries, right, from the first class, second, third, fourth, and fifth. 49.5, 69.5, 89.5, 109.5, 129.5, and the last one, 49.5. Right, the scales of the horizontal is the IQ scores. Then we have, well, the first class. We have the value is 2 of them, right? So the first class up to 2, maybe somewhere around here, we can mark it saying that's 2. Right, then the next one is go up to 33, somewhere here like 33. Then the next class go up to 35. Then the fourth class go down to 7. And the last class is go down to 1. I just mark it if you want to make it a little clear what you're doing, and shade each box. I just shade each bar, right, to make sure that it represents the histogram. Now we can see that shape. And also there is another thing called relative frequency histogram. Which not only use the frequency as the frequency of vertical scale, but we use the relative frequency as the vertical scale. So we put the relative frequency a column, and put in the result we have found, right? 2.6% and 42.3, 44.9, I believe, right? Percent, 9.0, and 1.3. Right, so for the relative frequency is this, and we construct the basically same thing as the relative frequency and IQ score. The highest is up to 45%. 5% each. As the gap of 5% in each, we could make the up to 45% as the relative frequency, right, on the vertical scale. And horizontal scale, we just need the gap of the data, right? Same use as the class boundary. 49.5, 69.5. Right, the horizontal scale basically is same, right? Then we go to the table, right? 2.6% is a little bit similar as 2.5, 42.3. Let's go up to maybe 42 somewhere, right? Somewhere as 42. Then go up to 44.9, which is about 45, right? And then go down to 9.0 and go down to 1.3. We could label it as what we put to make sure that, well, even though the graph may be not that much accurate as what it's supposed to be, but we know what it's supposed to be. Right, then afterwards we could shade the graph. I shade it. And pretty much we get the same shape of the curve, right? IQ score on the horizontal scale, frequency, either frequency as individual or frequency as relative. Right? Doesn't matter which one it is. It's either histogram or relative frequency histogram that we get no gap between the two pictures. Right? That's no gap between the not the two classes, or every two class that's no gap. Then that's pretty much we use, right, for frequency and for relative frequency as the histogram and relative frequency histogram. So let's see the next example. Histogram and the relative frequency histogram. And then we use the example of Oscar Best actor. I use the table provided for the Oscars Best Actor. 13, 6, and 1. Then we get 82 in total as the sum. Right? Therefore, if we construct to the relative frequency, we'll go to class boundary first, 19.5, 29.5, 39.5, 49.5, 59.5, 69.5, and so on. And for the lower and upper class boundaries, for relative frequency, we just divide each one by its relative frequency, by its total, right? 31.7. $42.7, 15.9, 7.3, and 1.2. Right, so that is our relative frequency. I just divide the frequency by the total 82 and whatever it is, right? And then convert to percent. Right, therefore for the histogram, I get the boundaries 19.5, 29.5, 39.5, 49.5, 59.5, 69.5, and 79.5 as the H. Then the vertical scale is the frequency we use that goes up to 35 still, right? Right, 5 as a gap. That we draw the curve, right? The first one has a frequency of 1. So maybe it's just underneath. Right, then the second class jumped to 26, which is a little bit higher than 25, right? 26. The next class is 35 people, and then we're up to 35. The next one is 13, right? 13. Somewhere. The next class is 6 of them. And finally just 1. Right, that is our histogram. Right, together with the frequency and the class boundaries. And when we do relative frequency histogram, it's similar. Right, for the class between 19.5 to 29.5 and 39.5, 49.5, 50, 69.5 and 79.5. That's the H, and we have relative frequency as the vertical scale, vertical scale as the relative frequency. Then what we have is somewhere between 1.2% all the way to 42.7%, right? So we can still use maybe use 4 as a group, 4 as a gap. In percent, that's 4%. We could write the percentage on the top that we get the scale to be in percent, right, to get that much, as one gap is to be 4%. That the highest is 42.7, so 1.2% is very, very low, somewhere, right. Could label it as 1.2%. The next one go to 31.7, which is almost 32. Then next goes to 42.7. Right, the next class is 15.9%, it's almost 16. And then 7.3. and the last one 1.2. Right, so that is the relative frequency histogram. Right, so basically histogram and relative frequency histogram should have the same shape. The only difference is, well, one is using frequency individually, the other use relative frequency as the percentage. But you could write the percentage when you draw the scales to put it on the side, right? The frequency in percent, then you get each gap means 4%, right? We just decide ourselves to make the scale looks good enough. And we see, well, the distribution of the two curves should be looking at least in the same shape. Right, so that is the histogram section. Right, the histogram section. The next thing called frequency polygon. For the example of IQ scores, right, frequency polygon, how we do is use the class midpoint and frequency. Right, that is the IQ score and frequency. What else we use is just the class midpoint. Well, we say before the XM as the midpoint of each class. Well, how to find the class midpoint is just the sum of two classes and divide by 2. Right? We found this already, 59.5, 79.5 of the class midpoint. Right, 119.5, 139.5. How we use them is we just use the midpoint with the frequency. Right? The frequency still goes up to 35. The frequency 5s gap. Oh, we use the point as what it's supposed to be. The first class we has a 2 as a frequency. We put a labeled as a dot, then go to 33, then goes to 35, then go down to 7, and finally go back to 1. Right, then what we do to the frequency polygon is just connect the points together, use straight line. Right, sometimes it will go down to the lower bounds. Right, attach the curve to the lower bound and upper bound. Right, sometimes they don't go down. Right, if we have a graph together with its histogram, we'll see that, well, that's our histogram, and so on, right, of each class. What it does is just connect all the midpoints together, then to be a line graph, right, instead of the boxes we have. Right, the boxes was from histogram, but instead of we have that, we just have the line graph. Right, and connect to each lower bound, each bound. Right, basically that is the frequency polygon. So try to use it to construct a frequency polygon for the Oscar best actor. Right, the H distribution of Oscar vector and its frequency. Right, frequency. That's 1, 26, 35, 13, 6, and 1. Right, we just need an extra column of the class midpoint. To construct the class midpoint, again, is the midpoint. Right, that is the sum divided by 2. Right, so 24.5, as we found already, right, 34.5, 44.5, 54.5, 64.5, and 74.5. That's 6 classes. And what do we do for the frequency polygon? We just draw 6 classes. Of 24.5 as the first, 34.5, 44.5, 54.5, 64.5, and 74.5 as the midpoint we use for the to represent the H. And the vertical scale we use is still the frequencies. 7 S. 5 as a gap. To go up to 35. And then the curve we use the midpoint and the frequency. Right? The first one is have a 1 as the frequency. The second class goes up to 26. Right? The third class go up to 35. The fourth class go down to 13, right? 13. The next one goes to 6. And the last one goes to 1. Right, so connect 6 points together by a line, straight line. Then finally maybe go down a little bit to the left and right, extend the graph. So to touch the x-axis by its lower and upper boundary of the first and last one. Right, so that's how we draw the frequency polygon. I basically use the class midpoint and the frequency to get the frequency polygon. And well, that's some other thing left over for next time, right? We will have one more graph, and this chapter will have some other things called scatter plot, and we'll finish with this chapter. Right? Next time, we'll wrap it up and go to the next chapter.